Hi, in this video I will build an FPGA design for our Linux project. This should not be new. I just want to show you the design I will be using. I will add a LED counter to this design in hardware. This will help us see that we have the right design before we are running any software. For an FPGA design, we need a folder, FPGA design, and we need Vivado, like I said, 2021.2. We'll create a project. We'll call it ARTY Linux Proj, and we'll direct it to our FPGA design folder. We don't need RTL. We'll go to boards, ARTY Z720, and the project is created. Next, we'll create a block design. We'll call it ARTY Linux block design. And we'll put our zinc, run auto connection, and we'll add some GPIOs. We need 4. 1, 2, 3, 4. Now we run connection automation. And rearrange the design. We'll add a debug ILA on the zinc bus so we can see the read and writes, and we'll extract the reset and the clock for our counter. Now we rearrange the design, and now, as you can see, it gives me false output, so I will remove them. The first GPIO will be to the push button. The second GPIO will be for the LEDs. The third GPIO will be for our RGB LED, and the fourth will be for the switches. As you know, in the ARTY board we have 2 switches, 2 RGB LEDs with 3 LEDs each, 4 LEDs and 4 push buttons. So this is our design. I just wanna decrease the size because I have here only one register. I don't need 64K for it, and it will be easier when we write the Linux application. And we changed the addresses. and we save our block design. Now let's make a wrapper, and we'll copy this to allow user edits, because we want to add the counter to it. Okay, we have it. We'll remove the outputs of the clock and the reset. We need an internal bus for the LEDs. We'll add clock signal and reset signal, and we put these changes in the design as well. And we take the LED's output and we build the counter. Now we connect the output LEDs the first three will connect to the most significant bit of the counter, and the last one will connect to the output of the LEDs in the block design. That's it. That's our design. But one thing we need more is constraint, because we disconnect the LEDs from the GPIO, so we need to generate a new XDC file. We call it pins. And I took from the schematics the pins that I disconnect from the block design, save it, and everything ready. I'll generate the bit stream. I'll pause the video and I'll come back when it's done. Okay, the design is done. We'll view reports. I can see here that I have no timing problem, so we can move on. First of all, we'll extract the XSA file, the hardware. We'll include the bit stream and we'll put it in our FPGA design folder in a new directory. We'll call it software. While the bitstream was generated, I added my camera so we can see the board and all the LEDs. Now we open the VTs. Direct it to our software directory. And we'll create an application project. We'll use the XSA file from the software directory. Next, we'll call this ARTY standalone, and we used a hello world template. Okay, we'll open the hello world and we'll start the software. First, we need to connect to our GPIOs. We'll find the GPIOs in the X parameter directory file, include file. We search for GPIO and we have the first one, which I remind you, it's the push button. Unsigned long PTN this one will be LED, this one will be RGB, and this one will be switches, and this one is 1, this one is 2, and this one is 3. Okay, now my software will run forever. And we need some variables. Int push button, another int for the switches. The RGB needs 2. In a minute I'll show you why. RGB LEDs 1 and int RGB LEDs 2. I'll add an int RGB out. And that's it. I plan that every switch will have an RGB LED. When the switch is on, the push button number will be displayed on the RGB LED. Now, first of all, the push button will take its value from the push button GPO reg 0. The switches will get its value from the switches GPIO. And the LED GPIO will get the push button output. For the switches, if switches and 0 if the first switch is on, we'll put to RGB LED 1, we'll give it the push button as you know, this is a 32 bits register, so I'll zero all the rest and I'll leave only the 3 least significant bits. Else this means that when the first switch is on, the RGB one will get the 3 least significant bits. For the second LED, this will open for the first LED, RGB LED. The second LED, I'll check the second switch. I'll use the RGB2, but I will shift it 3 bits to the left. So this one will get the numbers from 0 to 7, and this will get the numbers from 8 to 38. Now we combine the two for our RGB out. So we can check it in debug, and we'll place them in the RGB register. That's it. That's the software. And now for the board. Now before we load the board, there is here a jumper. It should be on the JTAG. Now it's on the SD card. We should put it on the JTAG, on this status, on this place. So the control is through the JTAG. We'll connect the board to my computer, and as you can see, the bitstream didn't load. It waits for me to load it through the VTIS. Now first of all, I need to compile my software. I did. And now let's configure debug mode. see that it had ARTY SA application, and here we reset the entire board, we program the FPGA, and we run the software. So let's debug. We're programming the FPGA, and now the LED is up. Remember this LED for the Linux part. And as you can see, the counter is counting. So we know that that we have our design on the board. This we will check also when we run the Linux. In the beginning, I'll do it step by step. My switches are, the first one is on, the second one is off. I'll press the push button and I'll check it, and it got the number 1. I'll check for my switches, and it got number 1, the switch is on. Now, next I check if switch 1 is on, I'm turning LED 1 to 1. Switch 2 is off, so I don't check, and I make the connection, the summand, and I still have 1, and I configure my RGB LED, and we have a blue light. So now I'll turn on the second switch, and I'll turn off the first switch, and I press push button number 1. So I got 2 in my push button, I got 2 in my switches, my first switch is off, my second switch is on, so I got 16, which is 10 in hexadecimal, and the blue LED is off and the green LED is on. And so we can run this program, and I have blue, green and red, and if I turn the switch back, I'll get blue, green and red. I can do both. This is actually my software, and once I have a Linux machine, I will change this to a Linux application. But this is the software, we can see it working. Now we just have to generate a Linux kernel, and this we will do in the next video. Thank you and goodbye.